guess I'm really happy to be here and see so many faces out here in the crowd, people that I know, people that I've talked to. It's really interesting, this Living Building Challenge, and one of the things that a few weeks ago, when we were first looking at a lot of these things, and we were talking about Living Building Challenge, one of the things that we really found as we've been working with Newcomb Boyd is that you really have to have a more integrated process and an integrated project team. And so today we're kind of going to be showing you an example project that we've been through, an exercise to kind of understand from not only a process, but also like what does it take to achieve Living Building Challenge in the Southeast. So going over today, we're going to be introducing the challenge, how to achieve the petals, and also have a little bit of a discussion about what are the relationships between us, how we all work together to actually achieve this, because it's a very aggressive target. There's going to be, it really requires a different way of working, a different way of thinking about not just throwing it over the wall to your engineer, as an architect, not just doing design and isolation from his consultants. Everybody has to be on the same team, constantly talking to each other throughout the process. So, again, Living Building Challenge. And also, I guess, one of the things that's important to remember is that there's 3 different ways you can do a Living Building Challenge. You can do it through renovations, landscape and infrastructure, and buildings, which is what we're going to be talking about today. So the Living Building Challenge is more than LEED is kind of, as we always know, it's kind of more of a points-based system. Living Building Challenge is trying to affect a change on the industry as a whole. And so what it's trying to do is change the way we work, change the way things are done. It looks at a broader community-based focus, so it's not just your site, but it's all the external negatives and positives that come from building the building.
So this slide coming up next is probably the one we've all seen multiple times. Anybody who has heard about Living Building Challenge knows and understands that there's 7 petals. But for all of those who haven't heard, well, there's 7 petals in Living Building Challenge, and the way these petals focus around a building is to create a holistic approach. We're not trying to create a checklist. We're not trying to create a point-based system. We get 10 points, we get 15 points. We're trying to create a holistic system around the building to be able to hit not just targets like water, energy, carbon footprint, but also petals that are, well, more important to us as people inside the building, to be happy, to appreciate beauty, things like biophilia. These are factors that Living Building Challenge really pushes out. So we're not just focused on making the energy consumption so low, the water consumption so low, that the building is almost not even fun to use anymore. Well, the reason we put buildings is to make them fun, and the challenge definitely embraces that to the full extent. And in terms of the certification types, the idea is that there's 3 major types that are offered at the time, but even so, the key idea out of it is that we can achieve Living Building Challenge in all these multiple ways. They're always trying to create a way to make it happen for you, because understanding that a lot of times all 7 petals, which is the first category out there, is not possible depending on the budget, sometimes depending on the site. And then we can just do the 3 petal certification. So where we are only targeting on 3 petals, of course, one of which has to be either water, energy, or materials. Or even if so, the project does not permit to do that, we can take yet another route, and that being our net zero energy building certification. So overall, the idea being the challenge is always evolving. They're able to cater, they're wanting to understand, listen to what the people are saying, what they can do, and just keep stretching the boundaries of design. And because of that, it's evident that people are embracing it. There's definitely an upward going curve, not just in America, but all around the world. There's more and more buildings coming, and there's already buildings in Southeast doing the Living Building Challenge. So it's definitely spreading around. People are picking up, and the more the people look into it and understand the different petals and why it's important, the more they become known and familiar, and to have the desire to do it even so.
So I guess, So I guess like one of the things that we wanted to do is instead of just giving you guys like a really long presentation with lots of bullet points, you're like, and I think most people would feel like, well, how does that apply to a building I would design? So what we did is we decided that for Georgia, we would actually make an example building, go through the entire process of creating parametric models that link to the engineering design, and try to see how, as both designers, engineers, and architects, we could try to like make a process and understand how that process could be for many of the projects that are going to be coming up in Georgia as the certification system becomes more prevalent. So for this project, we picked a 40,000 square foot kind of lab and school type space, and we went into a lot of detail looking at, how one of the things we realized really quickly is like the building form is really driven a lot by the requirements in the Living Building Challenge, because energy is such a huge factor, water is such a huge factor, materials, things of that nature. So it's important to not just like come up with a design that, from just sketching or just from a computer model or just from a computational model, but it's really, really important to make sure that you're tying that back to performance. So for example, in this project, we angled the roof down to meet the angle that is perfect for the sun. A lot of things like that are like, okay, that's a no-brainer. But sometimes, like our building form, especially the roof, is something that's just kind of an afterthought. In a Living Building Challenge, your roof is going to have a definite impact on the shape of the building because the PV array has to be so large. And Brendan he'll get into that later on when it comes to energy. So place, another thing that's really important about the Living Building Challenge is that they're wanting you to not just focus on your site. They want you to be focusing on the context as a whole. As architects, we all know in school that we're told, place, is really important. We got to make sure that we're being equitable to the people around us, that, there are, things like urban agriculture are a part of the Living Building Challenge, which is cool. Because then it starts to allow us to do all the things that we want to do, that we know we should do. Now there's an economic incentive to do that because the certification does add quite a bit of value to your building. Your owners are going to really be interested in seeing a Living Building Challenge because it's a differentiator. For example, the Van Dusen Center up in British Columbia in Vancouver, they had a dying, botanical garden. All the people who used to come to their botanical garden were getting old and dying off. And so their problem was like, how are we going to get more people to come to our botanical garden? So they built this Living Building Challenge project. Now it's so popular, they've had to increase the amount of solar panels because they have so many more people using the building. Their enrollment is way up. Cadillac shoots its commercials at the Van Dusen Center. So there's a lot of value that comes from creating this sense of place, from creating, buildings that actually are giving back to the community through some of the means that you see here. But that's kind of a context for how it's working.
All right, so let's talk water. Water in the Living Building Challenge is actually given equal weight as energy and as materials. When it comes to that petal certification, it's mandatory you get one of the three, either water, energy, or materials. And I think for a long time we've treated water as if it's free, comes out of the tap. We don't give it a second thought. And we've started to see that that's not quite the right type of thinking that we should go with. We're starting to see in California, from the drought that they're having, but even without the drought, I think you would still see this in that they have the groundwater, the reservoirs that are drying up. They're taking the groundwater out, and those levels are going down, and they're not getting replenished at the same rate as the withdrawal. And then even in the Midwest, in the high plains, with the Ogallala Reservoir, that reservoir is also decreasing at an alarming rate in some areas, excuse me. And between the high plains, the Midwest, and California, that's a significant portion of both population and food production. So water is going to be very important. It is starting to be more important. I don't think it's still priced, though, as important as it should be. We still pay too little for water. Even here in the Southeast, Atlanta gets its waters from the Chattahoochee watershed, and really just the upper portion, the headwaters. We don't even have a full river's length worth of water. We just have a small portion of it. And with the drought a few years back, we saw the consequence of that when the reservoir started going down. Since then, we've had more water, so people kind of forget about it. But it's still there, and it's still going to be an issue again, both from rising population, and we're going to see droughts again, and we're in a water war. We have Georgia, we got Florida, we got Alabama, all fighting for that same amount of water. So we need to treat water with respect and try to limit its use. As it relates to the Living Building Challenge, they want you to emulate the natural system. So the first part of that would be to mimic nature, what was here. If we were not here, what would the site look like? Around here, that would be like a Piedmont forest, where the rainwater is captured by the trees, the ground cover, and it pretty much percolates back in, and there's very little that sheds off. We do a lot of shedding off with our buildings. We go to the storm and it gets dumped into the rivers, and we have water quality issues that way. So they want to take a step back, and so you need to address the water that falls on your site and have none of it leave the site. The idea is that you're not connected into the storm. It's all through bioswales and on-site remediation of keeping that rainfall there and making use of it, which goes to the second part, is sustainable water use, that you have a carrying capacity of that site. Whatever water is on that site falls through rainwater, through the groundwater system, ponds, that is the water that you get to use in the building. So you're not connected to the main domestic water floating around the city. In Atlanta, you're not connected into the potable water system, that you're making your own potable water and gray water for use. And then, so we talked about the rainwater, we've talked about the water that you're using. Well, where does that water go? Normally, it gets sent down the sanitary sewer, and then that cost is externalized. Where that goes, we don't know, but it goes down the pipe. Well, we have issues with that in Atlanta with the combined storm sewer. Washington, D.C. has that, New York, a bunch of places have that, and then when you have a strong rain, it overflows, and you have sewage going into the environment. So one of this idea that everything stays on site, you've got to keep the gray water, the black water on site, treat it, and return it to the earth. So again, it shows that we're taking that rainwater, we use it, and we return it back into the ground to be used again and complete the cycle. You can use for the gray water and black water, you can use composting toilets, biofilters, bioreactors, constructed wetlands. You can even use a septic system if that works for you. And it may not work for a large building, but if you have a small site, septic system would also work as well. So there's a lot of options. It doesn't have to be this, whoa, how are we going to deal with that? There's a lot of options that we can use, and some that are actually being used here in the area. We'll get to that. So I wanted to talk about what's actually being done in the Southeast, because while we had that drought a few years ago, and it kind of woke people up to the issue at hand, and a lot has been done all across the state, UGA and Georgia Tech. I'm going to focus the next couple slides on what Emory's doing and some projects that we've had the opportunity and privilege of working on. So first one's Winship Cancer Institute. And this is kind of a base level. It's a very simple setup. We have air handling units up high. We have a cooling tower down low. There's no need for us to use potable water necessarily to make up water for a cooling tower, which just gets evaporated out. So what we've done is we've tied the air handling units into the cooling tower's makeup. We're able to save about 900,000 gallons annually. And it's a gravity feed. That means no pumps. We don't have to have any sort of tank or reservoir. It's a very straightforward system, and it helps reduce water use significantly. Second one at Emory would be Few and Evans Hall. We kind of take it to the next step. So that was very simple. Now we want to collect the rainwater as well, rainwater and condensate. And then in front of those buildings, there's a reservoir about 90,000 gallons. And then it gets pumped back into the building to be used for the toilet flushing water. So we're taking that water, which ends up being about 300,000 gallons of condensate a year. And overall, it's about 700,000 gallons, estimated at 700,000 gallons annually, which will make up about 90% of their need for that. So it's a great option. And one of the little side notes of this one, the pumps that actually pump it back into the building, because you got to have, if you go low, you got to pump it back up. Well, they're solar powered. So it keeps the sustainability thought in mind there as well. All right, so we want to take it then to the next step. We got rainwater, we got condensate. That's all kind of cleanish water. So why don't we take the water that's in the sinks, that's coming down the laundry, this kind of gray water, anything that doesn't have fecal matter, which would be our black water. And we want to use that for our toilet flushing water. So at Longstreet Means, we have 2 tanks, about 3,000 gallons. They collect the gray water, and then they get pumped back out. They get filtered, UV disinfected, and then they get pumped back into the a second set of pipes that goes to the toilets. And that's about 2,800 gallons per day that's needed. And so it's another great use of water that there's no reason that the water that's going into your water closet, your toilet, needs to be the same that you're drinking out of. So it's another great way of reducing water use. At this site, they actually use rainwater. They collect the rainwater and they use it for irrigation. So again, no reason to have potable water being used for irrigation. Why don't you use the rain that actually falls on the site to help irrigate? And then one we didn't get an opportunity to work on, but I love this project anyways, is their water hub. And this kind of takes it to that final step of the black water. So they have 3 main sewer sheds that head out of Emory. And this particular one that they tied into accounts for, I think, about 40% of their campus usage. It also connects to some buildings outside the campus, like CDC. And so they have pulled that water out of the sewer, and they've gone through their own water treatment system, bioreactors, and then they send it through this sort of wetland dish, and those plants love it, as you can see. It's a lot of great nutrients, and this is kind of the second stage. They also have a wetland area as well. And the intensity of how much room you have can lead to how much the intensity of the treatment. So if you have a lot of land, you can do a larger wetland and keep your energy use low. The smaller the area, the more intense the process needs to be. So it is site dependent. But they're able to take this water and return it back to the campus to make up for all their cooling tower water, their steam makeup, and also they're looking to connect it into dormitory or residence hall for, again, the toilet, water closet makeup. So this is a wonderful kind of scale jumping opportunity where you're looking beyond just the one site and you're looking at a campus-wide solution. It also supplies, it has a resiliency aspect where it has a 50,000 gallon storage tank associated with it. So they're able to keep operations running for about 7 hours, even if they lost water otherwise. And then I think it's about 150 million gallons annually that it processes. So wonderful, wonderful option for a campus-wide solution here in the Southeast. So then I want to talk about energy, the second of the 3 main petals. And really, energy is a pretty straightforward situation. We have to generate 105% for the full living building challenge. We have to generate 105% of the annual energy needs. You got to generate more than you use. It's as simple as that. There are some caveats to that, such as you need some on-site energy storage, and that's for resiliency. So that'll cover 10% of your lighting load plus any refrigeration needs that you have. The kick is that you need to have it for a week. So normally we size our storage for maybe a couple of days, or if you're on a natural gas, then you kind of assume that that natural gas will be there and you have a long-term backup. In this case, you're not allowed to use a diesel generator, and you pretty much want to stick with either batteries or a propane generator. So has to be thought of very much built into the design. But the idea is that we've seen over the course of the last couple decades that there's a lot of events, catastrophic events that happen around the country where you're not going to get power back in a day or two. And so this is giving you that resiliency of having a week where your refrigeration needs don't go out on you. You still have some lighting available as well. The other one is no on-site combustion. So the main idea behind this is that anything having to do with combustion, natural gas, is really just a stepping stone until we get to the final energy situation, which would be renewable energy. That because anything that we're combusting is a finite resource, and we're using more of that resource than is getting put back in, we don't have any more dinosaurs to put back into the ground to make oil, that we're pulling out more than we're putting in. So we need to just bypass that whole step entirely. And we're going to go straight to renewable and electricity. And so the last part of that is that to keep the energy mix alive, you got to sub-meter everything so that you can validate that you are producing this amount of energy. But there is an option for scale jumping, kind of like water. You can have a campus-wide solution. It doesn't have to be just the site. But you do need to be able to prove that your project is contributing to that campus solution as well.
Well, so as we learn really good detail about what needs to happen in terms of energy and in terms of water, the key reason why energy is one of the more important petals within the challenge is because, well, buildings do consume a lot of energy. We are 41% of all the industries, and that's a big chunk. And because we have such high targets, we do have a net positive goal. We can't be achieving it with the way we've been doing things all the time. We can't still throw our architectural drawings over the wall to our mechanical engineer and hope that two weeks later when we get the answer back, it's either a pass or a fail. It can't work that way anymore, and we need to shift the industry. That's what brings me to this McLeamy's curve, and mostly all that it's trying to show is that if those are our stages of design, concept, schematic, design development, and so on, if we start making more changes early on in concept, of course, we only have a sketch, maybe a SketchUp model, maybe a Revit conceptual model. That's all we really have at that point. And it does not take too much time to make the change at that time. And further on, if we start to make changes later in the design development stage, that's going to be a lot of more drawings to redo. That's going to be a lot of more redesign to do. So although currently our engineers in traditional practice, they'll come in more towards the curve 3 that we see, kind of late schematic, early DDs, sometimes even late DDs I've seen. We need to shift that, because if that's when we're making all the changes, that's going to be expensive. And as architects, I don't think we can really afford expensive. So we want to shift that curve, and we see 4, and I don't even think that's shifted enough. We need to shift it even further, pre-design all the way to there. That's when we need to start thinking about how to incorporate all these things. That's when energy, daylight, glare, all the things that we care about, all the things that the challenge cares about, need to come into play. We can't be hoping for the best up until the mechanical engineer hops on the project and hope that'll fix it. As a team, which is why the whole idea why we're working together, the whole idea why we're in a team is because for targets this stringent, we can't be unintegrated anymore. We need to be integrated. And so that here's a quick video to walk us through that process and the whole idea of introducing parametric early on in the design. So at any stage, as we're setting up a new project, there's just a site, we'll look at it, we'll do a basic site analysis, we'll look at psychometric charts, see if there's any passive strategies that work. In case of Georgia, not very many. But overall, we'll be looking at our windrows, our sun path diagrams. These are all the things that we start looking at just to understand the site. Then we have a program. It's usually, we'll look through the program. What are the requirements? We'll start translating that into our parametric model. And of course, there's not always a one-time fit, so we'll start playing with it. What's a way that we can make it work on site? What are the different options to incorporate the same program? And as we do that, we set up our geometry. And within the geometry, we can again change everything about our program, everything about our window wall ratio. These are the changes that we are making early on. And if we don't have this kind of information about energy and daylight early on, what are we even deciding our glazing percentages on? Is it all based off of thumb rules, or are we actually doing a real analysis to determine that? And to do Living Building Challenge, to be able to achieve all these goals, we need to start incorporating all of these elements much earlier on, and that's exactly what we're doing here. So we're changing our glazing ratio, and we'll link it directly with our energy calculator. And as we make any changes to the building, it'll automatically update. We don't have to go back or wait 2 weeks or wait even a few weeks to see what happens to the energy or to the daylight. If we update the geometry on our model, we immediately know what's happening to our daylighting picture, what the lux level looks like, where we need to be. We can make these decisions as an architect instead of just hope and guess and wait for it to happen. From all the experience, we all have become more or less good with making guesses, but they don't take us all the way, which is why we need to do analysis of this type. Again, tying in the water use before we put in all the nifty ways of making water use that Brendan alluded to. We need to, even as architects, start being very familiar. What are the strategies that we can do? Low flow usage and all of those things. We know that already. And moving further on, there's things like cost versus energy optimization. How do we produce the same type of building for a cheaper cost? Because, of course, our clients are not going to want to pay more. So this is what we do. We'll just put in all of our metrics together, all of our HVAC options, our wall options, our window options, everything together, put it in a big bubble and just toss it and run every option with every option to find the cheapest common optimal combination for the best energy performance. And this is a great tool that we use all the time for decision making. It's not about getting into the nitty-gritties of Energy Plus. It's not about getting our number right to the point, but it's about making decisions. And as architects, that's what we need most. We need decision-making capabilities earlier on in the process so that anytime we're making a choice, we're making the right one.
So then, just kind of going into that process, what would be some outputs of that? Like, let's say you've had a charrette, you have some kind of parametric model like Sandeep was showing, and you, as an architect, you're sitting there, you're sketching different massing schemes, and it's possible using parametric design to actually, test every single option in a charrette. So you can be sitting there in front of your client and actually be testing daylight models, actually be testing energy, and actually making good decisions in real time with the design process. And that's like what's really a key difference is when you start linking parametric design with mechanical engineering, with all the different consultants out there, then you can start to actually get to a level where you can, because we only examine typically on our project maybe 2 or 3 options based on our experience, when actually there's millions and millions of options out there. And so if we can use this process, then we're not just like guessing and like hoping that we're right, and just kind of telling the clients, okay, I hope, and kind of crossing your fingers. To actually be able to go in front of someone and say, like, we know specifically that this facade option is the best, this this wall option is the best, these combinations of materials are the best, and here's why. Like, that's a powerful argument, and I think that allows us, especially in a Living Building Challenge project, and especially in the Southeast where we're so challenged on energy consumption because it's so hot and humid, to be able to get to this level of detail as a designer is really key, because what you want to be able to do is you want to be able to know that if a 14-inch fin works better than a 12-inch fin or a 13-inch fin, and being able to have a really fine-grained control over the shaping of your building. And what we don't want is we don't want to just do the things that we always do, which is just design something, like we said, and hope for the best. We want to have like Brendan right there, talking about the energy and like having his inputs from all the models that they're running here on a constant basis, be combined with the architectural workflow, so it's all working together. And again, going to that as well as daylighting, this is really, really important for the health and happiness petal. If you have a lot of glare in your space, you can't use your computer. A lot of times, we don't know what the glare situation is going to be. So you want to be able to run these tests on your model in real time with your project, where you can actually check and make sure that the glare situation is going to be permissible or okay for your building. That level of rigor and due diligence from an architect is something that I think that clients who are going out there and trying to win these Living Building Challenge projects that I talk to, they're all getting into this. And I think most of the big firms out there do it. Even mid-sized firms now, I've heard of them winning projects just based on having a much more rigorous level of detail in the design process.
So as we're talking about energy and the site-specific locations, especially in the southeast, I just pulled up two psychometric charts showing Seattle and Atlanta, because one of the important things about the HVAC is that we have to design it around where the building is located. So what this shows is a plot of every hour of the year. And in Seattle, you can see most of it is lower than 70 degrees and kind of a cooler, more temperate, even does get fairly cold there, but it's fairly concentrated scatter plot there. And then for Atlanta, surprisingly enough, we have a whole lot in the hot and humid in that red area to the right and up, but there's actually a fair amount that's on the left side of the psychometric chart as well. We do get cold here in the winter, and it's a much broader sort of spectrum. So it's something to keep in mind as we design our systems. So as we kind of look at site-specific solutions, one of the recent projects we've done is the EBV project at Georgia Tech. And going to this kind of integrated approach is a good first stop. When we were looking at the design of this building, typically in most sustainable constructions now, we're adding some sort of shading device. And it seems like a given. We're going to add shading. We're going to add shading. We want to reduce the amount of solar gain. In this case, you can see on the east and west, we do have that shading. But on the south, we found that for the lab areas, that the solar gain was actually helping reduce the mechanical reheat that we needed in these high air change spaces. So in fact, adding the shading was a detriment to the overall energy use. So we went back and the shading is removed from that side. It also has radiant heating in the large kind of circulation spaces. Again, what this one gets to, the last one was reheat. One of the other big drivers in the southeast is fan energy. So radiant is a way to remove that fan, and so now we only need to provide the push enough air to meet our outside air requirements instead of the full heating or the full heating load. But that gets to an overall strategy when we're dealing with hot and humid or cold, and that is decoupling the outside air from the space. And so that's really a critical strategy, is being able to reduce the fan energy by decoupling. So we're not always pushing this air around, not always having to dehumidify and possibly heat this air, reducing fan energy, heating energy, cooling energy. One of the other projects, a great project that we worked on was NOBIC, New Orleans Bioinnovation Center. And this one takes what I like about this one is that so far we've been talking about the design team, design. And what the Living Building Challenge and as we, even general sustainability projects, is we really push the envelope that we need to involve the user and the owner in the decision making and in the way we reduce the load. So this project is not an owner-occupied building, such as like a college campus where the owner is going to be using that building, where they have tenants that come in, but these tenants are maybe they're high intensity lab tenant, maybe they're a lower intensity lab tenant, maybe it's just office space. And what this allows it to happen is the flexibility that any space could be a 10 air change module for that tenant, or it could be less. And there's a way to switch and reduce. That way we're not providing 10 air changes an hour to the entire space, even if that particular tenant needs 6, or maybe it's an office and needs less than that. So bringing the user in and still maintaining that flexibility is critical. And then even something as simple as lighting and the technology that you're using. We're pretty much at the point where LED lighting, even if you're not looking at straight up energy, LED lighting is making sense from a cost standpoint when you look at the life cycle. And so it's a great strategy to be able to reduce that initial EUI that you're looking at. Towson University is pretty much all LED, and we were able to shave about half of the lighting power density off of the code lighting that we would have installed. So getting from kind of those general examples to specific, as Patrick was talking about, we have the building, this hypothetical building, which conveniently is close to the size of the Georgia Tech Living Building Challenge building that's out there. But we wanted to take a look at this, how you look at the PV consideration, because it's not only driving down the energy, but it's also matching that to what you can actually generate on site. This sort of carrying capacity that I was talking about with water earlier. Well, we have the same situation with energy and energy generation. You can only use what you can generate. You can't use more than you're generating. So there's sort of you kind of have to work at both directions. So you can't build so Bullitt Center, 5-story building, makes it difficult to be able to do net zero because you have a lot less roof area than you do total building area. And so they had to drive down the EUI quite significantly to be able to achieve that. So it does lend itself to lower height buildings. In this case, 2 stories is probably about where you want to be, because that gets you a square footage that's roughly 20,000 square feet or so. So what we did is we took the baseline, kind of a code standard building, just to set it up, and we were at about 76 kBTU. And this EUI, energy use intensity, so it's 76,000 BTUs per square foot per year. It's kind of a standard unit that we measure our energy use by for these sort of projects. But it leads to a PV array of like 40,000 square feet. So we would have to have a 1-story building to be able to achieve this. And that's probably unlikely unless you're in a more rural setting. So then you have to start reducing your energy use, and you want to be able to reduce your energy use because PV is expensive. So you start looking at optimizing your energy, as we were just talking about, working with the architect to figure out strategies, envelope, your shading, glazing, and we're able to take just through some basic steps there, making the glazing better, adding the shading. We're able to take it down, 10%. Then we look on the inside, internal loads, lighting loads, and so a strategy is like the LED lighting, also lighting controls, daylight harvesting, and then also do reduce friction, where we're, instead of a kind of a normal, typical duct design, pump design, you look at how can I reduce the pumping energy that I need, the fan energy that I need, and also improve the plant efficiency through better equipment, and we can get down closer to roughly 50 kBTU. So we're making significant improvements in our energy use, and that is also allowing us to reduce our PV size down to a more manageable 27,000, which would be roughly our 2-story building if we had some additional PV. Maybe you put it in the front with a sort of a cafe patio area that could be an indoor-outdoor learning space. If you want to take it to the extreme and say, well, let's take a look and put a geothermal system in there. And that does a number of things. That increases the efficiency of the building. but it also eliminates, in the previous examples, I was using a water-cooled unit, water-cooled chiller. So we're going to have water use that we have to make up. That cooling tower uses water. We have a limited amount of water that we can make use of due to our site. So if you go to basically a waterless system, a geothermal, closed-loop geothermal system, then we don't have to make up that water. So that would be a benefit. And that takes us down to 35 kBtu. Now, that would be for a full geothermal system. And in the south, that gets tricky because we're cooling dominant. And so that means you, in effect, have to oversize. I say oversize. You have to size it appropriately so that you don't overheat the loop. So that takes a lot of land. It takes a lot of cost. And that actually may be more costly than your PV. So it comes down to this optimization. You're looking for all the strategies that you can accomplish that are, in effect, cheaper than PV if you're just kind of looking at a cost optimization model. But you're also looking at the size in terms of how much building you're going to have and how much PV you can actually fit on there. And then it also goes back to how you construct your building, because if you can slope your roof to match the tilt that you want for your PV, then you can tighten up your PV array. You're not just in rows and having to offset as if it was a flat roof. You can actually match the slope and keep the PV array tight and have less square footage needed overall.
So kind of the process that Brendan was talking about of, having, integrated with his team, like he can give you, based on a typical building, some EUIs and how much PV you would need. But like as an architect, I think you would probably struggle to say like, is this design I just came up with going to meet that or not? And you'd have to keep sending it to him, and like, and it could be a little like if you're in the moment drawing or sketching or using, whatever 3D modeling software you are, like you want to be able to get that feedback. So what's great is if you use a parametric process, you can take all the inputs from him and you can put it in there. And every time you like shift something around in your model, you can start to understand what is the impact of that. And then when you do send it over to him, it's not like, oh, like this is completely wrong. Like how could you even consider making a building this inefficient? So like, it's like, I think it's like a much faster, more fun way of working. And I think, so that kind of leads into health and happiness. So health and happiness is kind of this idea that you should, in your building, be able to encourage people to walk more, to have better air quality. You should also make sure that people that are coming to your site, which kind of ties a little bit into equity as well, that you're not making your site be adverse to the population around it. So making sure that people feel welcome to come to your building. So a great example of how the health and happiness worked out was when combined with materials and all the other really stringent qualities of Living Building Challenge. People in this one school in British Columbia, they had several employees who were always sick because they were in this older building with standard mechanical systems, and there was always some kind of weird, just standard building dust in the building that these people were asthmatic to. But once they came in, they really focused on having really good air quality and good materials and environments where people walked and there was plenty of daylight. All of a sudden, these people's health problems went away, and they were actually able to work on a regular 40-hour basis and put in the time, and they actually were saving tons and tons of money every year just on personnel costs alone from making a healthy building that people were happy in. Also, a great example is on the Bullitt Center. They actually made the stairs so that they were fire glazed glass, so that when people would actually be encouraged to climb the stairs, and they found that instead of using the elevators, most people take the stairs because it's glass and it has a really great view of out to the surrounding city. So things like that, those are design qualities, and that directly ties into indoor air quality. And everybody on the team, if you're thinking in terms of how can we make this a happy, healthy environment, in addition, that becomes a design problem that can really change the way your building looks and how it's used. So, I mean, these are the standard requirements. Like I said, it's not that much different than what we're doing already, but it's just making sure that you are focusing on, making spaces that people actually enjoy being in, so that they actually will walk through the spaces more. They'll use less elevators. People will just generally be moving around more. And because you don't want to make a building that people is so tight on all the different performance requirements that people won't enjoy being there. So from that aspect, I feel like Living Building Challenge is great because it makes you really think about everything and not just focus on hitting some points, but on actually making buildings that are enjoyable for people to be in. So materials. This is probably by far the one that everybody is the most, challenged by, because energy, we know how to do energy. It's just a matter of doing the calculations, having the right process, and having the right team. But when it comes to materials, there's other companies are manufacturing materials, and a lot of times we don't know what's in all those materials. And so Living Building Challenge introduces this aspect of advocacy, where you're actually going out and you're finding a manufacturer of a product, and you're actually verifying that they don't have all of these things that are called the red listed materials. So what's really interesting is, like, most everything in this room and everything that we're wearing probably has some of these carcinogens in them. And it's interesting, based on a lot of research from different neuroscientists and people like that, each one of these materials on the red list actually removes 5 IQ points from you as you're growing up as a child. So that's a lot of IQ points, each one. So 5, 5, 5, 5, 5. That's a lot. And we could always say there could have been something. We could have invented fusion if people weren't chewing on neoprene as a little kid. You never know. So it's important to, like, really start to get into that. Another great example is this next slide here, where this is how Living Building Challenge wants you to do it. The architects for this project, they were looking at the building, they wanted to apply this waterproof coating, and it had, like, some nasty stuff in it. And they're like, hey guys, can you actually change what you're putting this in? They're like, oh sure, we just put that in there because we always do it, but there's another one that is totally okay, and we'll put that in there. So they actually changed the formula of their waterproof coating, and now it's standard for everybody who buys their product. But that was an example of just asking the question actually changed the market, and now this building is not going to have a harmful material that could, stymie our technological progress in the future. Another thing too is, so like the whole idea is basically you're just trying to reduce carbon footprint. So many of your materials, they have limits on the distances that you can get them from, and then they want a certain amount of materials that are red list free, per square footage in the project. So that's kind of another thing too. It's challenging because there's not a lot of information on a lot of products that you want to do. So you do have to do a lot of research. So if you're looking to do a Living Building Challenge project, you need to be scheduling, several hundred hours of project time to people calling up manufacturers, writing letters, requesting information. A lot of manufacturers, they don't even know deep in their supply chain where their materials are coming from sometimes. Stuff comes from, all over the world to be manufactured in one place, and then it gets shipped to another place. And so by the time it gets to maybe, a major manufacturer of a material, like, they don't know, that somebody was putting cadmium in their toys in China. There's just no way to verify that sometimes. So Living Building Challenge says that's unacceptable. Let's actually know what's in our materials that we're putting into our buildings. So I think that's pretty smart, but it just takes some time.
And adding on to that, that's a completely realistic thing. As people living in today's time, we're used to, anytime we go to the grocery store, anytime we go to a restaurant, we always want to see the calorie counts. When we go to the grocery store, we'll always flip the product. We'll always look at what's really in it. We'll see that that's not something I like. I don't want it in there. Why should buildings be any different? And that's exactly what Living Building Challenge is trying to make us think. Why are we not doing the same thing? Why are we not wanting to know what's going in the buildings? Sure, we're not eating PVC, or we're not touching it all the time, but somebody at some point was investing their time to make that. They had all those fumes, they were taking it, and eventually when we do dispose it, somebody else is getting it. So the whole challenge is, again, about looking at a holistic way, a holistic approach to change the market. And now there's Declare label out there. It's a lot easier now to do a living building materials petal than it was about 4 years ago. Even there's people out there, manufacturers out there, that are saying that, yes, we are open to providing information, and yes, we're open to exploring how we can do things differently. And going back to the whole idea of the challenge being very catering to the market and not really sticking to its rules all the time, is because they understand that sometimes there's no other way of doing a thing. And they're like, that's fine. As long as you have done the right amount of research to show that this is the only product that you can use and there's nothing else in the market and there's no other way your manufacturer can make it, that's okay. We will make an exception as long as you make the effort to put in the research and time that maybe later we will have something better, something safer. So it's the whole idea about market evolution. And that again goes back to the whole idea of carbon footprint. And so we're not getting all of our materials from places far away. We have a limit to it, because thinking about the life cycle and embodied energy of the whole building, if we're transferring everything from over 3,000 miles, well, even 300 miles is the minimum, or the 20% must come from 300-mile radius. If we're getting anything from much further off, we have all of that carbon footprint to transport that material, all the embodied energy, the trucks, the planes, the ships, however it's coming, and we're using that in our project. So anytime we say we're doing a carbon footprint, it's a completely zero embodied energy building. Is it really? For a living building challenge, yes, it is. And that's a really key point that they bring out. And goes back to net positive waste. We've heard about waste, we've seen it, we've dealt with it in LEED projects before. Understanding the whole life cycle, where does the project start, what's the origin, and where does it end? And it's the whole idea of being completely informed of exactly what that cycle is and making sure there's no waste, making sure everything that we're using on our building is not a one-time use only, and then it's just a damage, an extra thing on the earth that we have incurred because of our building. So in this way and many more, the whole petal, and not just the material petal, is just surfaced around making sure we're thinking holistically. We're not thinking one time. We're not thinking one client, one person, one occupant, or even one group of occupants. We're thinking the world. We're thinking, how do we make this overall better? And that's where we're changing the conversation from, my building is efficient, it's net positive. What's it doing to the overall world? That's when it all starts becoming more interesting.
So also getting back to, they have this idea of equity as well, which is, you want to make sure that your building, they want to really focus on making sure that people who, from an accessibility standpoint, that every aspect of your project is, they want to make sure that every aspect of your project is able to be accessed in the same way by everyone. So just putting in an accessible wheelchair ramp, no matter, like, if it does take you sort of to the front of the building, they want every part of the project to be accessible to everyone. They also want to make sure that the local economy is being positively affected. They want to see local jobs. They want to see people actually being engaged. They don't want to see a bunch of contractors come in from out of state, do a Living Building Challenge project, and then leave and take all that money, that was made on the project away. They want to see that kind of being reinvested in the community, making sure everything's human scaled, making sure that the public spaces on the outside can be accessed by everyone, so we're not making these antisocial architecture. So I think it's kind of nice. I mean, like, as architects in school, everybody's taught, we want to make a nice building that everybody wants to be in. Then we get out in practice and it's like, look, the owner, he's like, make this park bench have like multiple sharp points on it so only people can sit in it and not sleep. Those kinds of things that happen later in life make you kind of jaded, but Living Building Challenge actually gives you financial incentive to do the right thing. And so I think that's really great. So beauty is another aspect. And I think anybody who's an architect should love Living Building Challenge just because beauty is one of the petals. And it's not like LEED where it's like, okay, as long as you check all the checklists, like, we could care less what the building looks like. The building actually has to look nice. And I think that's important because we should really be embracing the idea of all these materials. It's what we were trained to do anyway as architects, is to make things that are nice, that people like being in. There's a lot of market research that points to better design equaling better sales, more people coming to your space. Every Living Building Challenge project that I've looked at so far, every client has seen increased use in their building, increased rent, just because they have such a dynamic, interesting, well-designed, equitable, lots of good materials, very healthy, not too much energy use. I mean, it's just all around the ideal building that we all wish we could do. Now there's actually a certification that says, yes, my building has done everything that I could possibly do. So that's why I think it's like really important that some people would say, like, why are they testing beauty? And I think in the studio that Sandeep and I have been teaching at Kennesaw State University on the Living Building Challenge, a lot of the students had a lot of problems with, like, so you guys are going to be testing this on beauty? Like, how is that even possible? But I think, like, after a while we realized that, no, it's just about having a good design with a good concept, and that, it has a story. That's another aspect of this petal, that there's a community education component of it, so that when people come to your building, at least, once a year or something, there ought to be like some community outreach and programs to educate people on what is good design, what's good architecture, what's a good energy and water aspect as well. So I think from that standpoint, I think everybody who's an architect should be behind Living Building Challenge, bottom line. So I turn over now to Brendan here.
So we've talked a lot about our initial designing and getting it all correct, how we start early so that we can set the project up for success. But as we've talked about, two of the requirements, net positive water, net positive energy, are an ongoing commitment. And I think we've all realized that we spend a lot of time designing buildings, and then in the past, a typical thing is to turn it over, and then the building facility group starts taking it over and continuing the operations, and hopefully keeps it optimized where the design wanted it to be kept at. But that's not really a possibility when you get to a net zero building or net positive energy, net positive water building. You've got to evaluate that over time, and that takes an amount of energy input from everybody involved to keep that building optimized at the design level. So you kind of have this initial bit of energy a large amount of energy at the design. You're going to have a large amount of energy in this commissioning phase, a really deep commissioning, fine-tuning of the building to get it to where that design wanted it to be. And then you've got to continue it on over the life of the building. The idea is that you're not going to be net positive energy for 1 year, and then who knows what happens after that. But you want to be able to continue that on for a long period of time. So part of that can be continuous commissioning, fine-tuning, and whether that's the operators, if you have a great group of operators. But a lot of times those operators, there's not enough of them, there's not a budget for it. So you can incorporate some big data, sort of the power of computing, to also assist. This is going back to the project I talked about before, Nobic. This has an analytics software that's going to help us track the energy use of the building, make sure that we're on the target that we thought we were going to be on when we designed it. But it also allows you to keep track of specific areas that will make you understand if the building's going to start going off the rails. If some sensor goes out of calibration, well, who's going around all the time making sure those sensors are calibrated? Well, if you set up certain rules, you can be able to take a look, and the computer will be able to start saying when there's a divergence for you to take a look at. VAV box, it says that the damper is opening and closing, but you're getting no change in temperature. The reheat valve says it's opening and closing, but there's no change in temperature. It'll be able to alert you, flag that. Because the thing is, with a zero energy building, you can't wait a month or two for your utility bill to come in to say, I used twice as much energy as I thought I was. You've got to be able to keep track of it almost continuously. So it really is this kind of long-term commitment to the building, both from the owner side and really the whole team. We're in this together, which leads us to the project success.
So I think everything that Brendan's been talking about, the post-document C is really key. Like, for example, Living Building Challenge project at Van Dusen, post-occupancy, they came back and were checking their energy consumption, and they realized, wait a second, we are way out of line on energy consumption. Why is that? Especially in November and December. And then they realized that they have a festival of lights every year in the gardens, and they were like, oh, so we're using all this power for all these lights. And then they didn't realize that because the building was so popular, they had, you know, twice as many people coming per day, you know, that they had expected, and so they were using more energy for people coming in. And so that, but by tracking that and going back and forth with their mechanical consultants, they were able to understand that, no, we actually need to add another PV array on site to help power all these extra use to this building because it's so popular and people love it. So, I mean, I think that's a pretty cool success story that, you know, if our building's so popular, we need more energy. You know, I think that's a pretty good message. And I think then it really comes down to kind of the big summary. You know, there's a lot of information that we went over today. There's a lot of aspects. Each petal is complicated, but it's not really that much of a difference than what we do. It's just the ideal process. It's like what we should do anyway, but what we often can't because budget or just the way the incentives are for our project are not set up that way. So it really comes down to having a well-integrated team that every day, you know, you are not just, you know, every few weeks sending your design to a mechanical person. You're actually on a daily basis, you know, using parametric design, talking to your mechanical person, you know, really getting in there into the nitty-gritty as you go along and letting that be, instead of an annoying thing that you have to do is like, okay, we got to bundle this up, you know, flatten all the drawings and then send it to our mechanical consultants. No, it's actually like they're a part of the design team now. And we want to be able to have that really close relationship to be able to achieve these beautiful buildings. And I think that's the key. You know, really, Living Building Challenge is beautiful, but it's a great thing that I think every architect should be doing if they can obviously convince a client. But as we go through and continue to do more and more of these buildings, people are going to start getting down the process. Architects will understand that they need to change the way they work. Engineers already know that they need to change the way they work. You know, everybody's like together, you know, working as a team. And when that happens, like the whole world's going to be a better place, I think, in the next 10 to 15 years. So appreciate you all coming out. And I really appreciate the opportunity to really collaborate with the guys here. So thank you.
So open up if you have any questions. Well, the mandated part of that would be the net positive water, the net positive energy, that you're going to have to be able to prove during the occupancy that you are generating 105% of the electricity that the site is using in the water. For a certain period of time. It can be the set period of time, because a lot of times these buildings take a while to kind of smooth out the kinks. And so you're not going to start day one, everybody comes into the building and you're already generating more that first year. It may take several years to optimize the building to that point. So it's an ongoing process.
There was a question back.
Yeah, could you tell us a little bit about the process, how it would compare for when we're doing a lead project and we have the interface with GBCI, we know the architect's going to do these credits and the engineer's going to do these credits, and you have the dialogue, you're submitting your credits on a preliminary basis, and then there's a final acceptance and the review. Is it a similar process with the Living Future Institute and a similar procedure?
So yes, there is. Yeah, so I guess the question was, is the reporting requirements similar to LEED in that you have to file documentation and then have approvals done? Is that fair? So yes, you do have to do that. But Living Building Challenge tends to be more flexible than LEED because they know they're doing something innovative and different. So a lot of times, like if you can't get compliance on a certain material just because no one will manufacture it, but if you've written a letter to the manufacturer requesting that you need that material manufactured, they will count that towards that material element or something of that nature. So it kind of becomes more of more positive relationship with Living Building Futures Institute and all that. So I think that's a little bit better situation than LEED, where it's just like you submit and it gets approved, and there's no real dialogue as to argument to how the fine points of that point should be interpreted.
Yeah, and along with that, since they are really pushing the envelope in a lot of areas, the requirement, the goal is that you don't connect to, the city water, right? You do everything on site, that any potable water is from on site. And so if that's rainwater, and they don't want you to use chlorine necessarily to disinfect that water before it gets used, because that's on the red list. But they understand that not every health authority is going to allow you to do that. And so the idea is that as long as you can show that you've really tried your best to change their mind, to work it out with them, and they still refuse, then they'll make some exceptions. There's some exceptions built into the various things, but the intent is that you're working towards that as that change agent.
Oh, yeah, no, I have a couple of questions. Like the first one was, which type of relationship are between this Live and Challenge and the LEED organization? Are two different types of organization process, like two different type of entities, or one? It seems like this one is much more stringent. So it's like once you get this one, you get automatically some type of LEED certification as well. And the second question is like, it sounds you bring lots of new machinery and equipment to the building. So it's like even to maintain and operate all this machine, like how much more expensive at the end of the process is this compared to a more traditional type of tool? Can somebody figure it out? Because it all sounds cool, but sounds also much more expensive.
Sure. So the question is like, if you get Living Building Challenge, do you automatically get LEED? Are they the same? Are they sister organizations? And then is it more expensive to use mechanical equipment? Right. That's a higher level.
Yeah.
So I'll speak to, I guess, the Living Building Challenge is totally separate from LEED. They share common goals, I would say, but they're totally different, and their focus of Living Building Challenge is on reducing carbon and making healthy spaces. So it's kind of like a little bit, quite a bit different. And then as far as
the cost of the equipment that you're putting in there, it depends. If the idea is that we're working towards an integrated, project team, and because we're driving the energy use so far down, that everybody's impacted by everybody else. So there's a lot of different examples out there of ways to optimize the design to try to eliminate any potential cost increase. One is the typical VAV design, where you have large ducts moving a lot of air throughout the space. You need plenum height for that. Well, if you go to a DOAS sort of setup where you're just delivering the outside air to the space, and then you have local cooling, whether that's chill beams or fan coil units, then you're reducing the ductwork costs, and you're also potentially able to reduce the floor-to-floor height of the building. And that's real money. And so that will offset any sort of increased cost because you have this fancy DOAS system as opposed to a normal air handling unit. So that's really the key, is to come together as a group and think about how you can optimize the building as a whole. Even if you have one part of the system that may be an advanced system, maybe you can save it somewhere else. So potentially by going to net zero, depending on how you do it, you could be cost neutral to just a normal sustainable, highly sustainable building that didn't incorporate that sort of integrated approach.
So that's why it's really important to use things like cost versus energy optimizations. So you can actually not just optimize for performance, but also optimize and balance in terms of cost. And I think the other question that you had as well was if you get Living Building Challenge, do you get LEED certification? No, it's a separate thing. But you would definitely, if you have Living Building Challenge, you would definitely hit platinum. So that would be like the base, like you're going to be beyond platinum with Living Building Challenge.
How does it deal with existing buildings after the freeze?
The renovation side of things?
So yeah, for existing buildings, they have a certain number of petals that apply to existing as well. I think I'll bring that slide back up.
Sure. So it's everything the same, but just in terms of the parts that are being restored, and everything else still applies. So it does apply to renovations as well, and it's just about. Okay. So mostly what would happen is certain portions of the building that the renovations are happening, then they will be applied to the petal that or the challenge that you're trying to achieve. So the goals and targets and the ways of getting to them would still remain the same, but then it would just be targeted off to the pieces that we're focusing on instead of the whole building.
Got one more. What's this? I didn't understand the civilized site. What I mean, you're saying don't put it in DeKalb County, they're not civilized? Or what was that term?
Hey, I live in DeKalb.
So that's kind of like this aspect of equity, that you're not like introducing sites where, like, if a handicapped person comes to the site, or somebody who's just, had a knee operation, that they have to walk all the way around the site to get the entrance. Like, you're actually providing sites that are civilized to, like, not, discriminating against people by how your site is working, or the fact that you introduce like a lot of security measures into your spaces that discourage its use as public space. Things like that is definitely part of that. I don't know if that answers your question, but that's from what I've seen so far, that's kind of what that petal is about, that part of the petal.
So there are some conflicts in the state of Georgia between the forestry industry and the league. Do those same conflicts then exist with this rating system?
Yes. Yeah, you're not going to be able to use your non-FSC certified wood, but you can use site wood that's harvested on site and several other things. So they'll be flexible, I'm sure, but as long as your project is using like private money, it's not as big a deal. But definitely state money, there would have to be some kind. You would have to make the effort to change their minds on your project. But it's not a deal stopper though for LBC.
So that's it. Appreciate everyone coming out.